Next person is Wannes Meert from the KU Leuven on sport analytics.
Thank you. So I'm Wannes Meert and I work as a research manager in the Declarative Languages and AI group at KU Leuven. There's my nice start slide. And today I will be talking a bit about sports analytics, but I'll use it as an example to show where we want to go to in the future. DTAI is a large group of 70 people, and we're involved also in the Elucidata project that you've seen by now multiple times by CIRIS and Agoria. And DTAI is involved there with the full 70 people that we are. DTAI is split up in two big parts, machine learning, but also declarative languages and systems. And we work on this variety of topics. And today I will be focusing on the sports analytics part to show you where we want to go to in general, what our key ideas are that we want to focus on. So why is sports analytics interesting now? Because we have an abundance of sensors suddenly. We can measure everything from heart rate to where people are on the field. And that's what we want to use here. This data that's now available, that's where we're going to work with. So let me give 3 examples. And this goes very fast now suddenly. So you have physiological and inertial sensors that you can use, but also posture. These are very different measurements, but we can do very different things with them. The first thing we can use for fatigue or injuries, and this is joint work with the FABER, so the people of physical sciences. But we also have position and event data. We can look at game strategies. How is a player performing, not only physically, but also in the game? How is he positioning himself or herself towards the other players? And typically what we get is this table of data. And I want to encourage you, when you're collecting data, don't limit yourself to this one table, because your real world data is much, much more than that. You actually have a lot of relations in there. You have teammates, family, and these are relations, hierarchies, temporal data that you have within this data, and you should store this, you should use this or learn this, and if you learn them, you should reuse it later. Don't build models once, we want to have reusable bits of knowledge. And that's what we are using here in sports technology. So what we want to do is this reusable bits of knowledge that we can learn, these links that you have in your data, not just the pure tables, but also the links, and also these links, because they can be noisy. If you collect data from papers, there might be errors in your papers. Your NLP might not work 100%. There might be an error in the experiment. So you can build a huge graph of knowledge, and you want to use these links, but you have to also reason about how likely that the link is there or not. Or take a social network, or if you have sensor on your body, your athlete will not exactly attach the sensor to the position that you want him or her to position it. So you know where they are relative to, from each other, but you don't know exactly where they are. So you want to have some more generalization over that. Or if you look at the body, if you look at posture, basically you know that you basically have your arm that's attached to your body, and then you have your legs. So this makes that if you know this extra information and you have all these dots from a 3D camera, you can use this information to figure out how your posture is and how you're moving, what exercise you're doing. So that way you can give feedback to the user to say, like, this knee, a bit back, don't put your knee too far, instead of saying there is a millimeter error on that dot in your 3D graph. And if you look at what happens in games, and there we analyze a lot of data for the soccer leagues and the basketball leagues in Belgium, and then often makes the news, in that we want to basically create statistics that can give you an idea of why somebody is good at a certain game or not. So in our research group, what we think is the next, or we know is the next challenge, is uncertain and structured data. And structured here means it's a network. So I'm very happy to see mature products like Neo4j, where we see the graphs. Let's now add the probabilities also there. There is uncertainty in this world, and that's what we work on in our research group. General methods that can deal with these links with tables and probabilities. Thank you.